plus 8x squared. I'm going to take that 8x and multiply it by that 4, which will give me 32x. Are we good so far? Okay, then I move on to that 16. I have that 16 times that x, which will give me 16x. And then I have 16 times 4, which will give me 40 plus 24, so that would be 64 minus 2x minus 8. I think I'm going to let you combine like terms from there.
Okay.
Is that okay?
Yeah, I think I just forgot to add the 2x minus 8 at the end, so
Yep, there's just so much happening in that little tiny problem, and you have that little tiny space to do it in. A lot of math actually has to do with staying organized. If you write really big, to find a way to write a little bit smaller and a little more concise than writing all over the place. That is a math skill. I suck at it. I don't write very well, but I try my best. And it is a skill that I try to learn and perfect. All right, yeah, go.
On 17,
yeah.
when you have a negative exponent, how do you do that?
Okay. How would I do that if I had x to the negative 2? Do you remember that from the last? If I have x to the negative 2? We put a 1 on top of it and we turn it into 1 over x squared. So here if I have 3 times 9 to the negative 2. Now remember, PEMDAS says exponents first before you do the multiplication. So don't do 3 times 9 and then do your exponent. PEMDAS says you have to simplify this part first. So this would equal 3 times, well, we'd have 1 over 9 squared. That'd be 1 over 81. We would then have 3 over 81, and we could simplify that fraction. But do you see how I got to 3 over 81? All right, other questions? Yeah, go ahead. All right, number 9 says, I need a domain and I need the range. Well, see this little hole right here? If it wasn't for that hole, it would be negative infinity to infinity for both of them, because it goes all the way left to all the way right. It starts all the way down and goes all the way up. But I'm going to notice that we have a hole in our domain. I cannot enter negative 1. Negative 1 breaks this function because there's nothing there. So what I have to do is I have to say, okay, the domain still goes from negative infinity because it goes forever left. Now, once again, when I picture this, I picture if I squish this down here, my domain would go all the way in that direction. That arrow technically keeps going left and left and left. But then there's a hole here. But then it keeps going right and right and right and right. Does that make sense? For some people it makes sense, for other people it doesn't. Like if I squish this down, this is what I'm saying. It goes forever that direction. I have a hole right here, but then it forever goes in that direction. So writing that would be negative infinity until we get to that hole, which happened at negative 1. I can't use negative 1, so it has to be a parenthesis. Now I put a union, and I start back up at negative 1, which feels weird, to infinity. But let's talk about this. What I'm basically saying is it goes from negative infinity to infinity, but we exclude negative 1. The same thing's going to work from our domain. We go from negative infinity up until 1, 2, 3, 4. And then we go from negative 4 to infinity. So that would look something like this. Negative infinity to negative 4. Union that with negative 4 to infinity. Once again, if I'd squish this to make it look like it's on the y-axis, it would look something like this for my range. Negative infinity till I get here, pick up my finger. Got to put it back down almost in the same place, and then I go up. That's what this says, pick up your finger and put it back down. We have to skip something. Is this a function? Yes. Yes, it's a function. At no point can I draw a vertical line where it hits 2 points at once. Remember, that's the one rule. Don't go, oh, this hole is vertical asymptote. I don't care. The one rule is, if you can draw a vertical line that hits 2 points, it's not a function. If you can't, it's fine. All right, yeah. 18. Do you have a specific question?
Yeah, I don't know. Is there like an exponent in the 4?
Okay, so what did you say? Did you say 19 or did you say 18? Oh, 18. Okay, let's do 18. So 18 says we have 2 times a blank to the 4th minus 3 times a blank squared. I'm telling you, that's the easiest way to picture this. That when you have a variable, it's just a blank to put stuff in. They said fill that blank with negative 2x squared. So I have negative 2x squared here. I have negative 2x squared here. Now remember how these work. So we have to do exponents first. So that 2 is going to remain. I'm basically going to take that negative 2, I'm going to raise it to the 4th. I'm going to raise x squared to the 4th. When you raise an exponent to an exponent, you multiply. So that will be 2 times 4, which would be 8. Now we have negative 3. Now I have negative 2 squared, making sure you use parentheses when you square a negative. And then we have x squared squared, which would be 2 times 2, which would be 4. It would now be your job to do negative 2 to the 4th, which would become positive. Yep. And negative 2 squared is going to be a positive 4. So now it's just, now I have to multiply by 2. I have to multiply by a negative 3. We just got to be careful with our rules from there. Do you think that's far enough on that one?
Good.
Okay. Any other quick ones? I might have time for one more, and then we go on and come back if we have other questions. Yeah. Yep. 12, we're supposed to write each equation explicitly in terms of x. So we need to solve for y. How many y's are there?
2.
What does that mean? What is the operation I have to use if there's 2 and I need to turn it to 1? Yes. I need to factor it, which is, and I need to isolate the y by itself. In order to factor it, I need to have the y's all on one side and just the y's. So I'm going to move the y to the left-hand side and that x to the other side. So I have 3xy minus y equals negative x minus 6. So we move everything that has y's to one side so I can pull out that y. Yes, if I have 2 and I need to turn it to 1, I need to factor it out. That would now give me y times 3x minus 1 equals negative x minus 6. And we just have one more step. We need to divide both sides by that 3x minus 1. And then we have y by itself. And I don't care how many x's are on the other side. That's not the goal. The goal is to get 1y. But you are 100% correct. If I have 2 and I need to turn it to 1, it's usually we need to factor it out. Ryan, does that make sense?
Yes, sir.
It's a key algebra concept that you do need to know. All right. We've been doing that for about 8 minutes. I want to make sure we get through our lesson. If we have time after, if we have other questions, we'll go back and we'll answer questions. But we have a little bit to get through here. We got some very important stuff with just key concepts of general graphs. So now we're focusing on general graphs. The good thing is, if you understand it, the homework's really quick. It's not a ton of work. But if you don't understand it, it's conceptual. It might take you a little bit longer. So the first thing we're going to talk about are x and y intercepts. Intercepts are points where a graph intersects the x or y axis. The x or y axis. An x-intercept happens where, and this is kind of the weird thing, it's kind of the opposite of what you think it should be. It's where y equals 0. Perfect, I heard it. It's where y equals 0. It's where it crosses that x-axis, but that has to be where y equals 0. Because if you look here, if my y is 0, we're on the x-axis, and we're showing our x-intercepts. So if I'm looking for an x-intercept, I set y equal to 0. If I'm looking for a y-intercept, anyone want to guess what I said equal to 0? I put x equals 0. A function can have as many x-intercepts as it wants. It can have a ton of them. Picture sine. Sine kept hitting the x-axis, had an infinite number of x-axes. However, a graph can have at most one y-intercept. Because if it had more, it means it has to come back, which means it's no longer a function. So in order to have 2 of them, it would have to come back, which means it's not a function. So in order to have a function, it can have 0 and still be a function, but at most it can have 1. So if I ask you to find a y-intercept and you find like 3 of them, you probably made a mistake. So at most you can have 1 of them. All right, quick examples. Now, if I'm looking for an x-intercept, I'm looking for where my y value equals 0. So I'm looking at, I guess I can draw an arrow. I'm looking at right here. And I want to give that point. I want to actually tell the person, hey, look at this point. A point has an x value and a y value. So that point right there is going to have the x value 1, 2, 3, 4, 4, comma, 0. Which makes sense because our y value has to be 0. Just like when I list my y-intercept, my x value needs to be 0. So if I ask for a y-intercept, you should already go 0 comma something. It has to be. In order for it to be a y-intercept, my x value has to be 0. So even if I don't have a graph and I ask for the y-intercept, you say it's 0 comma something. Ooh, before I forget. That's right. Phones need... All right. So this particular y-intercept is where it hits the y-axis. So I'm just looking at this point kind of right here. I'll put an arrow to it. Right there is my y-intercept. That's where it hits the y-axis, and that's going to be 0, 2. All right, for our next one, we're going to notice that we have a few x-intercepts. I have, in fact, 1, 2, 3, 4 x-intercepts. We got to count for all of those. Now remember, all of those are going to have a y value of 0. So our first one is going to be negative 1, 0. Our next one looks like it's 1, 0. Then we have a 1, 2, 0, and a 3, 0. At most, it can have one y-intercept. And if I look way up here, we have a y-intercept. It looks like it's at 1, 2, 3, 4, 5, 6. So we should have that point 0, 6. Where does our next graph hit the x-axis? Yeah, go. You can have as many as you want. I brought up sine. Because sine, remember how sine just kept bouncing up and down? That would have an infinite number of them. The only way we'd list them is we'd have to do like that 2k pi kind of thing. Remember like vertical asymptotes? But yeah, you can have as many x-intercepts as possible as you want for a function, but it only can have at most one y. Do we see the next one hitting our x-axis? No. So how many x-intercepts are there? None. However, just because there's no x-intercept doesn't mean there's not a y-intercept. Because we can look up here and see that there is a y-intercept at 1, 2, 3, 4, 5. So that would be at that point 0, 5. Is that tough stuff? No. Is it stuff that needs to be memorized, what an x-intercept and y-intercept is? Yeah. So if you are foggy on that stuff, that just means we need extra practice on that. Don't get those wrong on the test or quiz. They don't require any algebra or anything. Just know what the terms mean.
That's the goal.
That's the goal.
Don't get them wrong.
That's always the goal. All right, next thing we're going to talk about are zeros. Now, zeros are specific items. They have to do with x-intercepts or y-intercept. Specifically, x-intercepts. So a zero is the point or points at which the function intersects the x-axis. So when I say zeros, I'm really asking for your x-intercepts. It's just a different way to say x-intercepts. When we say zeros, we're basically saying when is your y value 0? Because that's usually a really important idea. When is y equal to 0? Well, y is equal to 0 at your x-intercepts. So another way to ask for x-intercepts is, hey, dude, where are your zeros? Where does y equal 0? So to find zeros, you're going to set y equal to 0. And you're going to solve for x. I think we've done that a ton in Algebra 2, and this class where we solve for x when y equals 0. When I ask for your y-intercept, I'm really just saying, once again, find where x equals 0. Or in other words, for function notation, we want to figure out where f of 0. Start using a little function notation. Remember, this just says, when is x equal to 0? All right, examples. I'm going to, on the quiz, say, find all the zeros and y-intercept if it has one of each function algebraically. Now, I don't know how this one got crushed so much, but it's okay. We'll have enough room to do it. All right, so the first thing we're going to find is, let's go ahead and find our zeros. Remember, our zeros is when this whole thing equals 0. So we're going to have 0 equals negative x minus 5 plus 3. Now let's do one of the most missed things that people do not understand how to do with algebra. If you are solving something that has not addition or multiplication, like a sum operation, squaring, square root, absolute value, your first rule is always isolate. You should have to memorize it for every single time you do this. It is always, if there's something big happening, square root, squaring, absolute value, isolate before you do anything else. You'll be surprised, if you don't know what to do, how many points you can get for knowing to isolate. So the first thing I actually need to do is I need to move this 3 over to the other side. You have to. You have to isolate first. So I have negative 3 equals a negative x minus 5. Yeah? I have to divide by the negative because this is not isolated. In fact, this has a little hidden negative 1 out front. So you are 100% correct. I should not do anything until it's completely isolated. That means I just have absolute value on one side. So I need to divide by that negative or by that negative 1, which just switches the signs on both sides. So now I have 3 equals absolute value of x minus 5. That leads us to two situations. Either x minus 5 equals 3 or x minus 5 equals a negative 3. My God, is that so much easier to isolate it and then do that than some of the crazy stuff you guys tried on the test. Now all I have to do is add 5 to both of these, and I'll come up with x equals 8, or we're going to have x equals 2.
Bless you. You're welcome.
Are we good with that? All right, so I asked for zeros. You can give zeros the same way you did your x-intercepts. You can give it as a point. I can put those as 8, 0, and I can put it as 2, 0. But if I'm specifically asking for zeros, I'm specifically asking for x values. So you actually are okay leaving it like this. Or we can go ahead and use our braces and say I have zeros at, 2, 8. I guess I should probably put an x equals 2, 8. But you're okay. If you're on a quiz or a test, I'm okay if you just box those in. So if I'm looking for zeros, I'm just looking for the x values. If I specifically ask for the intercepts, I do need the points. Yeah. Did I answer your question? Yeah. Okay. All right, so now I'm looking for an intercept. So intercept means I'm asking for a point. I don't have to do any work to get the first part of that point because we know the x value has to be 0. Now, to get our intercept, we're just going to put 0 in for x. So to get our intercept, y-intercept, I'm thinking set x equal to 0. So that means in this equation, we're going to have negative absolute value of 0 minus 5 is going to, and we're going to add 3 to that. Well, we should do the subtraction inside there. So we have a negative 5 plus 3. Be careful with absolute values. It's not negative times a negative. It is negative times the absolute value of a negative. What happens when you do the absolute value of a negative? It becomes positive. So realistically, this is, and I think you said ultimately becomes negative, because we're going to have a positive 5 plus 3. So that is a negative 5 plus 3. Negative 5 plus 3 is going to be a negative 2. So that means our y-intercept is at 0, negative 2. Yeah, if you want to. All right, our next one, just as a quick recap, to find our 0, we set our f of x equal to 0, so we're going to have 0 equals x cubed minus 6x squared minus 7x. Now, here's what I want to get across to you guys. How long have you spent with quadratics between Algebra 1, Algebra 2, and this class?
Long time.
A long time. How long did you spend with cubics?
Pretty long, not as long.
Probably not as much. And you know why that is? Because we have really good skills of doing quadratics. We have less abilities to do cubics. So more often than not, if I give you a cubic like that, there's some way to turn it into a quadratic.
By factoring x.
We're going to see if there's an x in all of them. There's an x cubed, x squared, x. We can go ahead and factor out an x and say, well, this is just x times x squared minus 6x minus 7. It's a little math trick to know what you know and what you don't know. If you're like, hey, we don't spend much time on cubics, I bet you there's some way to turn this into a quadratic. So look for those little cheats right there. Okay, well, that's going to give me, maybe this is factorable. It isn't? I don't know. I thought you said no. How many ways are there to multiply? How many ways are there to multiply to get to 7? One. So we must, if it works, it's got to be a 7 and a 1. And in order for this to work, one needs to be negative, one needs to be positive. Does this work? And if so, which one needs to be negative? The 7 needs to be negative, and the 1 needs to be positive. Because negative 7 times 1 is negative 7. Negative 7 plus 1 would give me that negative 6. That gives me 3 zeros. I have x equals 0. I have x equals 7. And I have x equals a negative 1. We'll go down to our zeros and say, well, that's x equals negative 1. 0 and 7. I'm going to ask this to see if we're paying attention. Do I have to write it like this?
Yes. No. As long as we box it.
As long as you box these in. Remember, for zeros, I'm just asking for your x values. Would this be correct if I asked for your x-intercepts? Not for x-intercepts. Intercepts, I need points. Zeros, I need x values. So be clear of when you need points and when you don't. And if you're not sure, just give me points. Points always work. X values only sometimes work. All right, then my y-intercept. Here's the nice thing. We're setting x equal to 0 for our y-intercept, right?
Yeah.
What if all my x's were zeros? What is that going to equal? 0. So this we could do in our head. I'm going to go ahead and put it in my notes that my y-intercept is, we're doing f of 0, which would equal 0 cubed minus 6 times 0 squared minus 7 times 0, but we should have realized that's just 0. So my y-intercept is the point 0, 0. Questions on zeros or y-intercepts? Guys, if you have quadratics or something like that and you need to do zeros, your job, if I'm including zeros, is cross out anything that has an x in it because it's just 0. It'll save you so much time rather than plugging stuff in your calculator. It's just if it has an x in it, it's 0 in that part. So if I had a plus 3 at the end, you just go, oh, it's just 3 because everything else cancels out because of the zeros. All right, let's keep pushing on. Let's get to critical points. Critical points are where the graph changes. It's either changing its concavity, it's changing kind of the direction it's going in. I have direction and shape. Is changing direction or shape. So if you look at those 3 points I've highlighted on here, we have this obviously going up and also switches directions to go down. So that's a critical point. If we look here, it changes concavity. This is concave up and also switches to concave down. That is also a critical point. And finally, if it changes direction, it does that. So basically, if it changes direction or concavity, that is a critical point. Extrema are points where the graph changes direction. So that's where we have kind of the tops of the mounds or the bottoms of the mounds. We're talking maximums and minimums. The function has a minimum or maximum value relative or absolute to these points. A point of inflection is where the graph changes its shape or concavity, whatever makes sense to you. I actually put both words here because both make sense to different people. If you know what concavity means, it might make more sense to you. So either change shape or concavity, that's our point of inflection. Now when we talk about maximums and minimums, there are different types of maximums and minimums. So if I look at this graph right now, this is a maximum because it switched directions. Is this the highest place this graph goes to? It goes to infinity. So this is not the highest point on the graph. Is this the lowest point on our graph? No. So we have to tell the person that we're talking to that, yeah, this is a key point, but it's not the absolute lowest or absolute highest. So we come up with different terms depending on how maximum or minimum there are. So we have two terms. We have relative and we have absolute. The first one we're going to talk about is relative. So we're going to talk about a relative maximum. A relative max is a point with the greatest value compared to the points around it. Just the points around it. So it's when it just switches from low or from going up to down, but it's not the highest point on the graph. What is happening back there? Oh, you just have the stuck there. All right. If you are the greatest value on your entire graph, we can't state infinity. Infinity is not the greatest because we can't get there. But if we look at this graph, there is a point that I can say, oh, that's the highest point on our graph. That is called absolute maximum. So our absolute maximum is the point with the greatest value over the entire domain of the function. It is the highest point that graph gets to. We do not list an absolute maximum if it goes to infinity because I don't know what number infinity is. It's a really, really, really big number that I can't comprehend. It's not a number, correct. All right, if I'm a point that is the least value compared to the ones around me, I'm called a relative minimum. I have seen textbooks where they call those local mins and maxes. I'm going to stick with relative because that's the more conventional one. If I'm the lowest point on the graph where I change directions, then I'm going to be my absolute minimum. All right, our next point, and this is really what I want to get to, we're going to be using our calculators for one of these. At least one of these. So it says, give the coordinates and classify the extrema for the graph of each function. Use your graphing calculator to approximate if necessary. So our first one, do we have an extrema? Is there something that changes direction? Because we go from going down to going up. So I'm looking at this point is an extrema. Now it looks like some kind of minimum. So let's go ahead and name that point. That point is 1, 2, 3, 4. 1, 2, 3, 4, 5. So that would be, we have something at 4, comma, negative 5.
Does everyone else read it left and right like us?
Like other countries and stuff? Yeah, as far as I know, graphs are always, because we didn't come up with this system. I mean, this is...
I thought it was made in India.
It was made in a bunch of different places. Descartes got famous for doing this, and Descartes actually did it in a notebook off to the side. It wasn't his big thing. They just found it in his notebook off to the side, hey, that's a really good idea. But China had their own thing, India had their own thing, but the white guy got credit for it is what typically happens. But there's evidence of it existing all over the place. But the good thing is, because these all came together from different things, we all have the same ideas of how to read it. Now, 4, negative 5 is an extrema. Can someone tell me what type of extrema? I said it's minimum. Would that be a relative or would that be an absolute? Absolute minimum.
There's such thing as an absolute maximum?
Yes. Yeah, we just covered that. That would be this one. Yeah. In fact, what is this point right here? That would be an absolute maximum. What would this point be right here, down here?
Relative.
That would be a relative minimum.
And the other one would be relative maximum.
Yes.
I thought he was talking about the algorithm. That's why I said.
And this would be a relative maximum. Now, when you look at these graphs, do these look like these are at points that you can read?
No. mean, the one on the left, yeah, but
Maybe, well, I can't even read this. Like, maybe it's at 0.5.
I mean, like the one on the.
Yeah, this one you could. No, I don't need a calculator for this one. This one I need a calculator for. So this is where we have to have a calculator. You're going to need it for the quiz. Good idea to learn it. I did put a little thing for key buttons to push. You can put whatever notes you want in there because you need to know how to do this in your calculator. So the first thing you need to know is where your y equals is. So I'm going to go ahead and I'm going to hit my y equals. I'm going to hit my y equals, and I gave you the equation for it right above it. I put negative. Now, be clear. Hopefully I don't have to do this. This was I had to do with geometry. This symbol is different than this symbol. This is subtract. That's not going to work there. I need to start with a negative. I want negative, and I have x to the fourth. So I'm going to go x is right here. We're going to raise it to the fourth. So I'll go to the... Oh, that looks like a fifth. No. I think my thing's off. You are not happy with how I'm pushing this. All right. So I have it to the fourth. Oof, that took a while. Good thing I'll have this saved now. So I have negative x to the fourth plus 4x squared. Then I have minus 2x. I hope you guys can do this faster than I can with this stupid thing up here. Minus 4. Do we all have that entered in?
Yeah.
Okay. Then we're going to go ahead and we're going to hit the graph button, which is on your top right. Now, here's a good button for you guys to know. Do you see the zoom button right here? Can we all find this zoom button? Yeah. Get used to doing zoom, and it's called zoom 6. Do you see how number 6 says zoom standard? We're going to do some manipulating, moving things around eventually. It's a good idea anytime you graph something, just do zoom 6 so you're in the right place. That we all start at the same place. You probably are because you haven't done anything, but your graph should look exactly like that. If it doesn't, hit zoom 6 and it'll look just like that. Yeah?
Mine said error.
Yours said error. All right, do you have other stuff in it? And I'm going to type in, that was my absolute maximum I found.
Yeah.
Absolute maximum. I rounded to the hundredths, so I said it's negative 1.53, comma, 2.94. We're going to walk through this one more time.
Is that a negative, or you just...
I have a negative 1.53 and a 2.94. Oh, or that's not a negative out front. It's just saying that I guess I could use those instead. All right, now let's find our relative minimum. So hold your questions until I do my relative minimum to see if you know what's going on. I'm going to go back to my calculator. My relative minimum is right here. It's close to that y-axis. So this time I'm going to hit second. Once again, it's second, calculate. And your calculate, you can calculate zeros, you can calculate maximums, you can do minimums. I'm going to go to minimums. I want to be left of that point. Do you see where my crosshairs are right now? They're to the left of it. If you want to, you could equal. I usually try to get a little bit closer just to let my calculator get closer to it. So I'm going to hit enter there. Then it asks for me to be the right of it. So I'm going to scroll right until I'm to the right of it. Maybe about there. Then I'll ask for, it didn't even ask for me to make a guess. It just went right to the minimum. Sometimes it'll ask for a guess, other times it won't. So my minimum should be 0.26 and negative 4.3 or 2.5. Yes?
If it says guess, will you...
Guess, just try to get close to it. So you just try to get close to that point. It means it's not quite sure which one you wanted, so you make a guess at about where it is, and then you hit enter, and then it'll be good. So my relative minimum, correct me if I'm wrong because I don't have it up there. Was it 0.26?
0.26.
259, which that'd be 2.6, negative 4.25. Let's do this one more time together. What am I trying to find next? Is that a maximum or a minimum right here?
Right there.
Yep. What's the last thing I need to find? It's a relative maximum. Relative maximum. We need to know what they're called in order to hit our second calculate, because if you don't know that's a relative maximum, you're going to be finding a minimum and your calculator is going to yell at you and it doesn't know what's going on. So I am finding a relative maximum. Good thing is I just have to say it's a maximum. I'm going to hit enter. It asks for a left bound. I'm already to the left of it, so I'm just going to go ahead and hit enter here. It asks for a right bound. So I'll scroll right until I'm to the right of it. This one does ask for a guess, so I'll get close to it. I'll be honest with you, you don't really have to make a guess. You can usually just hit enter twice. The only time it makes you guess, if you somehow your left bound and right bound had two maximum or minimums in there, then you have to guess at it. But as long as you isolated just one, the guess, I've never, in my history of doing this, I've never had to put the guess in correctly. I just hit enter and it usually finds it. For me, 100% of the time. Okay, so our relative maximum should turn out to be 1.27, comma, negative 2.69. All right, if you need help with your calculator, we're going to have to do it else because I need to move on for right now. Practice it at home because they are part of your homework. The last thing we need to talk about are increasing, decreasing, and then we're done with this. Increasing, decreasing, I forgot who brought it up. Who brought up the fact that I was reading the graph from left to right? You need to understand that we read graphs left to right to understand increasing or decreasing. You always read graphs from left to right. If while reading your graph from left to right, you are going uphill. So if we look at this graph, guys, if I look at this graph and I kind of picture my eyes, as my eyes read left to right, I am looking upwards, which means this part would be increasing. So this part right here would be increasing. If going left to right, I don't go up or down, that will be our constant. And finally, if reading left to right, I'm going downhill, I will be decreasing. So, if I look at this, we always ask for intervals. Remember, this arrow means it will forever keep this trend. It doesn't mean start reading the graph from right to left. You're still reading from left to right. You're just basically saying if I looked all the way to the left to infinity, my eyes would have to go up from negative infinity until I got to an x value of negative 1. You must use x values to do increasing or decreasing or constant. I will say that one more time. You have to use x values. The only time you ever use y values are for range. So if you're not sure if you should use the x values or y values, use the x values because they're used more often. You should try to know when to use the right ones, but if you have to, if someone's like, should I use the x or the y, and you think it's a 50-50, pick x values because those are most likely correct except for on ranges. So this will increase from negative infinity until I get to an input of negative 1. Now, here is the next weird thing about this. Can we all look at this fancy demonstration I'm about to do? Am I moving forward or backwards? Neither. You don't know if I'm moving forward or backwards until I move. So at any given point, you are not increasing, decreasing, or constant, and that's why we will always use parentheses for increasing, decreasing, or constant. Because at this point, I'm switching over between increasing and constant. So you will never, ever, 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 ever use brackets for increasing, decreasing, or constant. They will always be parentheses. So when is this constant? This will be constant from x values of negative 1 until we get to an x value of 1, 2, 3, 4. Once again, use parentheses. And then finally, when are we decreasing? We're decreasing from 4 to infinity and beyond. All right, given the intervals on on these functions, tell me if it's increasing or decreasing. Okay. what can help is just write on the graphs. I've seen it help out a ton of people that if they just write things on graphs, it helps. So for me, I'm picturing, well, we are not increasing, but we are decreasing all the way down until I get to there. So we're decreasing forever until I get to that point there. At that point, we switch over to increasing. Reading left to right, my eyes go down, and then they go up. Our key changeover point is this x value here. 1, 2, 3. I don't know why I paused like I'm going to keep counting. It's at 3. So we have kind of a changeover point at 3. So realistically, the only number I care about is 3, because everything else has to be infinities. So this is decreasing forever until I get to x value of 3, which would be negative infinity to 3. We're going to increase once I get to 3, and I'll keep increasing forever. So if I watched with my eyes would go uphill forever. That would be a boring life. But if you had to, your eyes would go upwards forever. Preguntas? Nada. Gracias. Let's draw on this graph. That way, if I get anything wrong, I can at least get points for understanding stuff. So what does this graph do first? If I'm reading this left to right, does it increase or decrease first? It decreases. So what I'm kind of picturing here in my mind is I'm picturing that we have kind of this changeover point right here. I'll even use a dashed line to say, okay, it's decreasing. Then what does it do? And then it increases until we get to this point way up here. Oh my God, that's horrible penmanship. That should say increasing somewhere on there. Give me 1 second, I'll answer your question once I can actually write increasing. I'm just going to finish my thought here, and then I'll answer your question, okay? So it decreases, increases, and then does what? So it decreases, increases, and then it decreases to finish off. Just write that stuff on there. Then at least I know what you're trying to answer. All right, yeah.
Do you use a union for the two decreases?
You can, not a union. Typically, we usually just put commas between it. But you can use a union. I don't know why we don't. We just don't. We usually just put commas between it. All right, so we're decreasing at 2 different points. I can name the first point. It's decreasing from negative infinity, and I can see this. So that's why I do this dashed line, because I'm like, oh, that's at 0, right? But the problem is I don't know this key changeover point here. Where can I find this point? I can use my calculator. In fact, I only really need the x value. I need my x value. So I'm going to very quickly, I'm actually going to let you guys do this. Plug in your calculator. You want to find your maximum. That means you're going to locate your left hand, your right hand, and your guesstimate.
Wouldn't you not use a union because something else happens like in between?
Something happens between it, but you can use unions when stuff happens between it. Because stuff happens between unions. Like there's gaps of information. Like when you union domains and ranges.
But is that a gap in information or is it something else is in between it?
Oh, yes. No, I understand what you're, yeah.
Okay. I just didn't know if there could be.
I'm just saying like you could use unions. But obviously, that's probably what they're getting at. They're saying that, hey, it increases here, and then something happens. So look for where something else is happening, and then look back here. Versus doing our union. Union kind of means, like you said, it's usually a gap of information. But it's basically telling you, look somewhere else for what's happening here.
So we have to use the calculator for all of these, right?
Not all of them.
Most of them.
All right, guys, did anyone get an x value for that point? Yeah.
2.67.
2.6? 2.67? So my x value would equal 2.67. Can anyone confirm with the 2.67? Okay, remember I don't need the y value here because that's why I drew that line. So that means we are going to decrease from that 2.67 to infinity. And we're going to increase between the gap. That's from 0 to 2.67. So we're going to use our calculators for two kind of things. First thing, we might have to find relative maxes or minimums. For these, we have to find just our x values to see where they switch over. So for increasing, decreasing, and constant, you just need the x values. For absolute minimum maximums, you need your x's and y values. I got a couple minutes left. Are there any questions on anything I covered today? Yeah?
Would it not be negative since decreasing? Negative and negative.
Nope. We're using the plain old x values. So I'm just using what's on this x-axis, negative infinity, until I get to this x value, which is 0. Then from 0 to 2.67, it's increasing. And then from 2.67 forever. So we're just naming our inputs that will get us those values. So don't worry about negative. Increasing, decreasing, you're just looking at the graph and you're deciding what's happening, and you're picking the inputs that make that happen. Is that a little clearer? So if we look at this one, I just know it's decreasing from here to here. So that means I'm looking at, guys, I'm still talking to someone. So that means I'm looking at inputs that go from negative infinity to right here. I'm actually just looking at the x values. So I'm not looking at, positive, negative have nothing to do with increasing, decreasing right now. We're just doing the inputs. It's a positive 3 because it crosses right here. So I'm looking from here to here, it's decreasing. From here to forever, it's increasing. I don't care where it's increasing, how it's increasing. I'm just stating that it's increasing, decreasing. So we go back here, and we're decreasing until we get to this point. So I'm naming all the x values until here. Then I'm saying it's increasing from this x value to this x value. And then it's decreasing from that x value forever. All right, you're not describing how high, how low, or anything. I don't have to know what it looks like. I just need to know it's increasing, decreasing at those particular points. All right, questions on any of that? Let's look at our homework real quick. Be aware there will be some asymptotes, vertical and horizontal asymptotes. I'm looking if there's any that will like creep up on you. Maybe number 11. Maybe number 11 that has a horizontal asymptote at -3, so I'll never get lower than -3. I think that's the only one that really has. Like I said, this homework is basically, take your time on it. Don't just look at the answer key. The answer key is not going to help you at all. Either you understand what increasing, decreasing, or constant is, or you don't. Copying the answer keys again. And look at how much work I had to do on most of these problems. If you're using the answer key for this, it means you have no idea what you're doing. And good job getting the 2 points. I don't care. Now you failed the quiz, you failed the test because you didn't take the time to learn this stuff. I think a lot of us realize that not doing homework in these sections doesn't help. Even missing one homework. It's a big thing to miss. We need to stay on top of these. Some of you are in danger of failing the class right now. Don't not walk because you just couldn't try your last semester of pre-calc. All right? Give me all you can because I'm giving you all the stuff I think is important for any class after. Even that means you're not taking a math class. You probably have to take a stats course or something. Most college degrees require you to do something in math, and this will at least make it a lot easier on you if you just stick around with me and you go through these key concepts. All right.